This is one of the questions that many learners they don't know how to actually do. So one of the learners asked me to upload it. Okay, then I actually promised to do so. So this is f of x. As you can see, this is the cubic function, and we do have g of x as the linear graph. As you can see, we are given these points here, and this is the point of intersection of the two graphs. We have c, we have x-intercepts of f. F is the cubic function, and L and M are turning points of the cubic function or of f. Then they want us to show that b equals -5, c equals -8, d equals 12 if it is given that the first derivative of the cubic function is whatever that's written on your screen there. Then this is the original. Then we are given what its derivative. Then what we can do, we can actually derive this f of x. We can derive this f of x. Let's try to derive it, as it still has what the unknown variables. So let's try to derive it, because we do have its derivative having the values of b and c. So let's try to derive this original. So it will be 3x squared plus 2bx plus c. And as you can see here, that what we have as 3x squared here, it's what we are having here on the original graph when we derive it, meaning 2bx will be equal to negative 10x here, meaning if we can equate them and solve for b. So therefore 2bx equals negative 10x, then we divide both sides by 2x to make b the subject of the formula. Then 2x, then positive 2 and this positive 2x and x, they cancel. Then we have what? Negative 5 here, which is what they wanted us to show, right? We are done. Then for us to solve b, or to show that, c, you know that the derivative, since it's c there, it's equal to what? Negative 8. That's negative 8. They correspond with the derivative we are given. Then for us to find the value of d, they want us to show that d equals 12. Let's try to do this. I hope we're still together, and if we are, please do subscribe to the channel. They want us to find the value of d there, and we know that d is what we can actually take b and substitute it on the original graph to find the value of d. Okay, let me try to do this, but I hope we are together. So this is very, very important. You say negative 16 into 2 to the power 3. Okay, but before this, let me just write our f of x with all its variables or values. So f of x equals x cubed minus 5x squared minus 8x plus the d that we are required to solve or to show. Then we can actually take that point b and substitute it on the graph of f. Therefore 2 cubed minus 5 squared minus 8 into 2 plus d. Then you can punch your calculator and make d the subject of the formula, meaning we're going to have, let me just try to use my calculator here. We have negative 16 equal to negative 28 plus d. Then negative 16 plus 28, we're going to have 12, I guess. Yes, so this is how you solve these types of questions. We have 4 marks. And if you didn't watch those other videos, I was showing you guys ways on how you can show that a equals b, a equals whatever and b equals whatever. Make sure that you watch it. It's here in our playlist. Make sure that you try to watch it and do like the videos, okay? Let's try to solve 8.2. They want us to determine the turning points, which is L and M. So the most important thing is that its first derivative, you can actually use that f of x that we have from our graph. So you can write f of x or f prime x as you are given equals 0. This we do this when we determine the stationary points. Then we do have the derivative, which is okay. We have the original here as it's is x cubed minus 5x squared minus 8x plus 12, or you can just take that one that you are given there. Then let's actually derive this. I hope you understand, and we equate it to 0. Therefore 3x squared minus 10x minus 8, not minus 8x but minus 8, sorry about that. Then you equate it to 0. Then you solve for x values of the stationary points. You can use quadratic formula, plus or minus square root the discriminant, that is equivalent to b squared minus 4ac over 2a. Then you're going to actually substitute that, and your answers are going to be, you use your calculator. So these values that you're going to get here are x values of the stationary points, and after that you're going to substitute them not on the derivative but on the original graph to find the corresponding y values. I hope that makes sense. So x equals 4, or x equals negative 2 over 3. Then you're going to take these x values and substitute them on the graph of f, the original graph. Then it will be f of 4. Let me just change the color. F of 4 equal to, where there's x, you substitute 4 so that you can find the y corresponding value of the stationary point. I hope it makes sense. Let me try to use my calculator here, but do confirm with yours so that we can have same answers. It gave me negative 36. So this is the first stationary point. Then the second stationary point, f of negative 2 over 3 equal to, you substitute it on the original graph, the graph of f, the cubic function. Then we'll have what? Try to use your calculator as I'm using mine here, so that we don't have mistakes. So it's 400 over 27. Then it's negative 2 over 3 is to 400 over 27. Then they want us to actually be specific which is L and which is M here. Then we know that M must have a positive x value and L must have a negative x value. Okay. Then this must be M. No, it can't be M. Why? Because the x value is positive on this side. So we'll actually use this becomes M. This becomes M and this is L. I hope that makes sense. By judging on the Cartesian plane, if you understand the properties of the Cartesian plane. Then they want us to determine here what the equation of G, the straight line, the linear function. Alright, now you can see that we have point before those points. Let's just write our equation. Now we cannot actually find the equation of G or Y if we do not have the gradient. Therefore we can use point C and point B to calculate what the gradient of the graph or of the straight line. And you know that line line segment BC and line AB, they are collinear points, meaning they have the same gradient, meaning we can use the gradient of BC as the gradient of G. I'm not sure if you understand that, by using what? The gradients formula from analytical geometry. Okay, let's just do that, meaning we calculate for the gradient of MBC. I hope you understand that. So the gradient of MBC equal to delta y over delta x, which is y2 minus y1, x2 minus x1. I hope that makes sense. So AB and BC, they are collinear, meaning they have the same gradient. So negative 16 minus 0, 2 minus 6. Then use your calculator. You're going to have negative 16 over negative 4 it's going to be positive 4. Then this is the gradient, meaning we do have, as we know that a is greater than 0, and it makes sense that our gradient becomes positive. Therefore, we know that the gradient now is positive 4. Then for us to find the value of q, you can use either point B or point C to substitute it so that you can find the value of q. 4 into 6 plus q. Then we solve for x, we solve for q. We have 24 plus q, then q equals negative 24. Therefore, the graph of G equal to 4x minus 24. So this is the equation of G, the straight line. I hope it makes sense. As you can see that it cuts the graph on the negative y-axis, which is negative 24, the y-intercept. I hope that makes sense. Now, they want us to continue. Let's just continue and solve for 8.4. I hope this makes sense, guys. Okay, so let's try to do 8.4. So it is further given that the coordinates of P are x equal negative 36, determine the length of AM, meaning we can use distance formula. But what we know here is that we do have the coordinates of M as it is the turning point of the cubic function or the graph of f. We do have the coordinates here, and we can use these coordinates as they want us to determine what the distance of AM, the length of AM. So here what we have is x is to negative 36. Therefore, for us to do so, we must first determine the value of x and use the coordinates of A and M to find their length. I hope you understand that. Okay, and the most important thing, you know that the y values of these points are equal. As you know, we determined and we calculated the coordinates of M before. I hope you understand that, or you remember that. Let me actually write these coordinates is 4 and negative 36. So for us to be able to do so, we can actually take the value of the coordinates of A and substitute them on the graph of G so that we can find the x corresponding value. I hope that makes sense. So we'll take the very same point and we substitute it on the graph of G so that we can find the value of x. So this is 8.4. Let me just actually make it neat. So we have 8.4. I hope you understand this. We're going to take that point and substitute it on the graph of G, the very same graph that we were determining. So we'll substitute point A. We know that y is negative 36 equal to 4x minus 24 because we're solving for x. Therefore, negative 36 plus 24, we're going to have negative 12 equals 4x. Then we solve for x. X equals negative 3. Then the coordinates of A, negative 3, is to negative 36. So, and this is point A. We do have the coordinates of M. Therefore, distance of AM equals square root x a minus x m squared plus y a minus y m squared. Then everything is under a square root. Then DAM negative 3 minus 4 squared plus YA is negative 36. We have negative 36 over here because that's the y value of point A. Negative 36 minus the y value of point M. Where is point M, or the turning point, which is also negative into negative 36. Then you put 2 brackets squared. You do it like that even when you punch it in your calculator. Then our answer, let me try to use my calculator here quickly. Square root negative 3 minus 4 squared plus open bracket minus 36 minus open bracket into minus 36 close bracket and the bigger bracket, then squared. And we have 7 units. So this is the distance of AM, the length of AM. I hope that makes sense. So this is how you're doing it. This is how you're solving these types of questions. And here they're asking for which values of x is the graph of f. Is the graph of f increasing? And is the graph of f concave up? If you watch the first video where we were actually explaining the sketching part, we touched on increasing and concave down as well as decreasing. So what you must do, first derivative greater than 0, then you solve for x. That's very important. That's what you do. And for concave down, meaning first derivative greater than 0, solve for x, that's increasing. Then for concave down, second derivative less than 0, then you solve for x. I hope that makes sense. That's how you're doing these, guys. So if you didn't actually understand what I was doing here, start afresh the video and listen to it carefully. Then if you understood it, please make sure that you do it. You like the video, you share it to your friends, because these are very important questions whereby you will be asked or you'll find them in an exam. So please like the video. Thank you.